Hi, welcome to this course on building ETL pipelines with PySpark. My name is Dio Bemikole, and I'm a solutions architect. ETL, extract, transform, and load, is the backbone of data engineering, and choosing the right ETL tool is key to balancing performance, scalability, and simplicity. Not all ETL tools are created equal, so let's break down when PySpark makes sense. To do this, we're going to compare it to tools like Pandas and SQL-based ETL. So we see Pandas is great for small datasets in Python scripts or notebooks. SQL-based ETL works well inside databases for structured data using tools like dbt or store procedures. And PySpark is built for large-scale, distributed data processing on platforms like Databricks, EMR, or Azure Synapse. When your data gets too big for one machine or you need more power, PySpark is the better choice. So even though PySpark is powerful, it's not always the right tool. For small datasets, Pandas is usually faster and easier. If you need real-time, low-latency processing, other tools like Kafka Streams or Flink might be better. And if you're doing simple transformations with SQL, using the database directly is often more efficient. So it's important to match the tool to the problem. So PySpark really stands out when you're working with large datasets that don't fit on a single machine. It's also great when you need complex transformations that go beyond standard SQL. And one of its biggest strengths is being able to handle both batch and streaming data in the same framework. So in conclusion, when scalability and flexibility matters, PySpark is a strong choice. So I'm over here in my Databricks environment, and you can see here that I have my module for this course called M1. I'm going to go ahead and click on that. But before I do, it's important to note that everything that you're going to use in this course is inside of your exercise files, and it's highly encouraged to download them and set up your own environment as you follow along. So let me go ahead and click on M1. And inside of M1, we have our notebook where we're going to be running our first PySpark notebook. So over here inside of the notebook, the first thing you want to do is make sure that you are attached to a cluster. To do that, go ahead and click on this button over here and click More. And you should find a cluster. And if you don't have one, you have the option to create a new resource here, which will then give you the option to create a cluster that you can use to run this notebook. I'll go ahead and press attach for this cluster. And the first cell I have here is the cell to start your Spark session. Fortunately for this demo, we're running this inside of Databricks, so the Spark session is already running, so you don't need to run this script. But in the off chance that you're running this outside of Databricks or in a standalone environment, you'll need to run this to enable the Spark session. All right, the first thing we're going to do is load a sample dataset. And the dataset we're going to be working with in this course is the video streaming dataset. And right now we have this saved inside of the Databricks file system, also known as DBFS. Just to give you a view of what that looks like, I'll go ahead and show you how to access it. So going over into the toggle navigation here, I can go into Catalog, and I'll click on Browse DBFS. And over here I have PySpark, video streaming, and you can see all the things we're going to use for each of the modules that we're going to be working in. So I'll click on module 1, and we have first job. And within there, we see the streaming sample 10K CSV file. So that's the file we're going to be using in that notebook that we just saw earlier. So let's head back into the notebook. All right, so let's go ahead and load the CSV file into a data frame. I'll go ahead and press run. And there we go. The CSV file has been read into a data frame. Now let's go ahead and see what this looks like. I'll go ahead and run this. And this is what the CSV file looks like. And one thing to note is you have the option to either do a display on the data frame or do a .show on that data frame. So if you use a display option, you get this tabular format like this. However, if you use the show option inside here, it looks a little funky like this. So I prefer this method, so you might find me using this a lot more. If you're using this in a different environment, you might find the .show option looks a lot better. But in this case, the display option is what we're going to be using. So moving further down, let's go ahead and see how much records do we have inside of that data frame. There we go. You probably got a sense as to how many records just by looking at the name of the file. It said 10K CSV, and we have 10,000 streaming events inside of there. Now let's get a summary of the different types of devices that are being used inside of the CSV file. And we're going to do this by using the group by clause on device types. As we saw earlier, device types is one of the options that we have over here. You see we have web, TV, tablet. So let's go ahead and do a group by to actually see what that looks like. Oh, there we go. So this is a breakdown between the web, TV, tablet, and mobile devices that are being used. The next thing we're going to do is save this as a temporary view so we can use SQL queries on top of it. To do that, we're going to use the create or replace temp view option, and then we're going to give it a name to save it, which we're going to call streaming events. And once we've done that, we can then use Spark.SQL to query this data directly. So I'm going to go ahead and run this, and there we go. We're able to save this as a temporary view, and now we're able to query this and see the amount of event counts that are happening in each of the countries within the data set. Now that we've done this, we can now save the process data to a new location. And the location we're going to call this is called process data. And it's going to be saved under the first_job folder, which is the folder that I showed earlier. And when this data is saved, it's going to be saved as Parquet. And this is done because Parquet is a much more efficient way to save data. So let's go ahead and run this. All right, the data has been saved successfully. We can go back into the folder to see if it's there. There we go. We have the process data folder, and this is the Parquet file that was just saved into this folder. This is our first exposure into PySpark using this notebook. And with this notebook, we've been able to load data, perform basic analysis using DataFrames API and SQL, and we're able to save the results in an optimized format. These operations would form the foundation of a production ETL pipeline when scheduled and automated as a job. Let's talk about reading structured and unstructured data. We know PySpark supports diverse file types for flexible ETL. And in this clip, we're going to explore how PySpark reads data from multiple data sources like CSV, JSON, Parquet, ORC, and Delta Lake. As you see here, we see where each of these formats fall between structured and semi-structured, as well as what they're optimized for. We're also going to go into handling schema with PySpark. You have the option to go with schema inference, where it's a fast and automatic approach. However, it does come with some risks where you run into the risk of having incorrect data types. You also have the user-defined schema, which gives you full control over your schema and also ensures that you have consistency and accuracy across your data. So let's go into our Databricks environment and see what this looks like. All right, so over here in our Databricks notebook, I'm gonna run the first two cells. And these first two cells are just some setup cells that we need to make sure we have the right Spark imports, as well as defining our base directory for the video streaming data that we're gonna be using. So starting with CSV files, you can see here that I'm using the .read.csv with the header equals true. And we also have infer schema set to true. And what this does is automatically detect column types. Using the infer schema option is convenient for exploration like we're doing now. But in production ETLs, when you have a lot of data, you want to make sure your job is spending less time inferring schema and more time doing everything else like extracting the data, transforming, and loading the data. So due to that, you want to make sure you define the schema, which we'll talk about shortly. So I'll go ahead and read the CSV file and see what we get back. So over here, you can see we have the schema here. And these are the different columns that make up the schema and the different data types that go with each of these columns. And further down, you see a sample of the data set that we're working with for the sample CSV file. So over here, you see we have the schema that we just got from the previous cell. And now that we have it, we can explicitly define the schema before reading the CSV. So let's go ahead and do that. So there we go. We've just defined the schema. The schema should be the same. And we are reading the file just the same. You might not see too much of a difference here, but you're just seeing the two different approaches you have to reading data within PySpark. Now let's move on to JSON files. For JSON, PySpark can handle both single line and multi-line formats. JSON is excellent for storing structured data with nested files. So you see here, we're reading the JSON file and you can read it with schema inference. And what we're doing after that is reading the schema and then printing out what the data should look like. So let's go ahead and run this. There we go. We see the schema and we see what the data looks like. And going further down to the next cell, you can see here that we are explicitly defining the schema just like we did with CSV, except this time we're calling upon the schema. Since we've already used it in the CSV cell, we can use it again in this JSON cell. And the schema is called streaming_event_schema. And we're just going to use that to read the JSON data. There we go. There's our schema. And there's our JSON data. One thing you notice is that when you read it without the schema, it looks a little different than when you do read it with the schema. Looking at it here, event ID is the first column. And scrolling back to where we read it without the schema, buffering count was the first column. So when you define the schema, you get to decide what order you want the data to be in. So that gives you a little bit more control. Now let's move on to Parquet. So Parquet is a column format that's optimized for analytics, and it stores schema information within the file and offers excellent compression and allows PySpark to read only the columns it needs, making it significantly fast for most ETL workloads. So you see here, we're reading the Parquet file, and the Parquet file stores the schema information. So as a result of that, explicitly defining the schema is not usually needed. So let's go ahead and run this and see what this looks like. You see the schema is printed out here, and we also get what the data looks like over here. The next format we'll talk about is ORC, and ORC stands for Optimized Row Columnar, and this is a highly efficient columnar storage format. The setup here looks pretty similar to what we've done before, and what we're doing in this example is just creating a folder to store the ORC file. And to show how this works, I'm just going to create an ORC file from the CSV data that I showed earlier. So first we define the ORC path, then we write the data as ORC from the CSV data frame, and then we just read it back like you see here. So let's go ahead and run this. There we go. The file has been created. We can see the schema, and then over here we also see the data. And this is how you can read data in ORC format. The last format we're going to talk about here is Delta Lake. Delta Lake builds on Parquet file format, and what it does is it adds ACID transaction, schema enforcement, and time travel capabilities on top of the data. So this is a very important format to know about, and it's pretty straightforward to create. All I'm going to do is do the same thing we did earlier by writing the CSV file that we had and writing it in the Delta format. So let's go ahead and do that. There we go. We can see the Delta schema that we have here, and we're also able to see the data just fine. So this is how we're able to read structured and unstructured data across multiple different formats like CSV, JSON, Parquet, ORC, and Delta Lake to connect to databases and cloud storage. We're going to do this by connecting to two external data sources. The first data source we have here is an Azure SQL database, and I have a table in my video streaming database called users. And the second source is a cloud storage, and this is known as Azure Data Lake Storage, which is also called ADLS for short. So in this ADLS environment, you can see that I have a folder, and you can see the folder structure in here. Right now, we're looking inside the raw folder, and within there is the video streaming data specifically for the year 2023. So now that we've set the stage on the two data sources that we have, let's go ahead into our notebook to see how we could connect to it. So just a FYI, you might see me jump around in this notebook. However, I have organized this notebook in such a way that you can run it in the order that I have it placed. So feel free to follow step by step, and that will work just fine. So scrolling further down over it to cell number 6, you can see here that to connect to Azure SQL, you can do this via a JDBC API call. And here's the layout for that connection. You can see here that I've parameterized the SQL credentials like server name, database name, username, and password. Databricks allows you to use widgets to pass information like this. So if you scroll up to cell number 3, this is where I've created some widgets, which I've ran earlier. But for your knowledge, I can press it again just so you can see how it runs. And over here is where you can put your credentials, which will then be passed down in cell 4. And in cell 5, I give you the option to remove it just so you have a much more cleaner UI as you run through the rest of the notebook. So since I've already done this, I'm going to go straight to cell 7, where I'm going to read the Azure SQL credentials and then display the result over here. So let's go ahead and do that. And there we go. We've been able to set up a connection to the Azure SQL database, and we can see information like the user ID, sign up date, subscription tier, preferred genre, gender, and many other columns. Now let's go ahead and do the same for Azure Data Lake Storage. You can connect to ADLS in a few different ways. And the way that I choose to do this for this demo is by specifying the ABFS path, which you can see here. And ABFS is the protocol used to interact with ADLS. And to authenticate, I use the Azure Storage key. And I do this by specifying a widget here. And over here, I pass in the Azure Storage key credentials. And just like before, I'll go ahead and run the cell just so you can see what the widget looks like. And then I'll take it away just so we have a cleaner UI for us to continue on. All right, let's go ahead and read the data. There we go. Now we're able to connect to the streaming events that we have inside our Azure Data Lake Storage container. And in here, we see things like the event ID, user ID. And if you remember, when we look at the Azure SQL database, we also have user ID information in there. So let's scroll up just to refresh our memory. There we go. So that tells us that we can actually combine the user ID from the Azure SQL database with the user ID from the Azure Data Lake Storage results. So let's go ahead and do that. So in cell 14, you can see here that I'm combining both datasets by joining them on user ID. And further down, I'm also going to group the results by subscription tier, which allows us to quickly analyze which subscription tier generates the most streaming activity. So let's go ahead and run this. And there we go. You can see we have a bit more activity for the premium tier compared to the basic tier. So this is how you can use the flexibility of PySpark to connect to multiple data sources and combine the data for valuable insights. For extracting data with PySpark. And we'll also see how to optimize our data ingestion process. And we'll do this by talking about batch and incremental extraction. So if you ever wonder why you want to optimize for extraction, well, the best answer is to reduce time and cost. When dealing with large-scale data, how you extract that data can significantly impact your pipeline's performance and resource consumption. So let's go into our Databricks environment to have a look at these two main extraction approaches. So I've gone ahead and defined our data paths here. We have full datasets for batch extraction and 3 data files for incremental extraction. And this includes a base file and 2 daily incremental files. So I'll go ahead and run this in the cell before that. All right, now let's start with batch extraction. So I'm going to go ahead and run the next cell and talk a bit about what it's doing. In this approach, we load and process the entire data set each time the pipeline runs. As you can see, we're loading the first full data set of 100,000 records. And this is the simplest extraction method, where we just read everything all at once. However, in the real world, instead of 100,000 records, this could be millions or even billions of records. And if that's the case, using batch extraction can be inefficient. But continuing on with batch extraction, we'll do some basic filtering to simulate this batch by filtering out nulls and do some simple transformation. You can see now that we've been able to filter it down to about 90,000 records. Now let's go ahead and save this as Parquet, which is a much more efficient format for analytics than CSV. And there we go. So as you can see, batch extraction is straightforward, but if your data set is large, this approach means you're repeatedly processing data you've already handled before. Now let's move on to incremental extraction. So let me go ahead and run this. You can see in this example, we're loading our base data of 50,000 records. And you notice I'm adding a data source column just to help us track where each record came from. And as you can see, we went ahead and wrote this out as our initial processed data. I'll go ahead and run the next cell as I talk through it. In this cell, it's day 1, and we have new data to process. First, we load our current processed data to determine what's already been processed. And then we find the highest event ID in our process data, and this is our watermark that lets us know which record we've already seen. So let me go ahead and run this next cell. And you see that the next thing we're going to do is we're going to load our day 1 incremental file. And if I scroll down, you see that we have 25,000 total records here. And the key here is that we only process the records with an event higher than our watermark that we just saw earlier. That way, we're only handling new data. So if I run cell 10, you see here that we're appending the new records to our process data. So you scroll down here, you see that the new updated record is now 75,000. And that's exactly what's expected when you combine the current process data frame with day 1's newly added record. Let's go ahead and look at the distribution. And when you look at this, you can see that the base data source has 50,000 and day 1 has 25,000. And that's exactly what's expected. So moving on to simulating day 2, let's go ahead and run this cell. And as you can see, this is similar to what we did for day 1. We get the new watermark here, and then we load day 2's data, and then filter for just the new records and append it to our processed data. We now have a new final record of 90,000. So let's go ahead and scroll down to look at the distribution. And of course, our final distribution shows we have data from all 3 sources, our base load data, our day 1 data, as well as our day 2 data. So when we compare batch versus incremental approach, batch is simpler to implement and is good for small data sets or when you need a complete refresh. But it's resource intensive for large data sets and leads to longer processing times. When you compare this to incremental extraction, you find that it is more efficient for large data sets, and this results in a faster processing time and it reduces resource consumption. However, it is more complex to implement because you need to track watermarks and there's potential for missed records if it's not implemented correctly.